Hello everyone, welcome back. I'm going to read some chapters from my new book, Intense Design, and it's a follow-up book. I hope you find it interesting. Maybe you're going to be building something while you listen to this because it's a bit peculiar for me just to read my own writing, but I thought you might enjoy it. So this is from chapter 15, Accelerating Design. Time spent in design is long-term payoffs. Freedom to make mistakes often dictates the speed of the design. If a design must work the first time, such as a bridge, then the design procedure has to be either very codified, conservative, or a complete copy of something already done. If you work in an area where mistakes are allowed, well then, go ahead and make mistakes. If you work in a culture that doesn't allow mistakes, you will be like a civil engineer designing a bridge. However, even the creative task of design can be made more efficient. Here are some ideas to accelerate the process. Number one. Well, let me read all these ideas. I hate just to read this thing, but anyway, the first one is get insight, and I'll expand on this. I'll just read from it later, but get insight. Number two, take risks. Number three, identify deal breakers. Number four, make decisions quickly. Number five, think of your design as part of the system and be willing to change the system. Number six, trust your gut and chase your hunches. Number 7, design by building. Number 8, design for 99% optimal. Number 9, don't be a zealot. Number 10, champion your design. Number 11, share ideas. Number 12, use existing designs where you can. Number 13, don't be enslaved to procedure. 14, test until you can sleep soundly. And then I continue on. So I'm going to run right through these, and again, often what you learn in design, you learn not between the pages, but under the fingertips. So let me read from the first topic here, get insight. Albert Einstein said, quote, "If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it." Understand the essence of the design problem. Insight doesn't come from a customer statement or data. It comes from understanding the desired final result. Insight also arises from blending other factors into your evaluations, such as visionary goals, cultural norms, social impact, and brand identity. You need to process information, including the customer's articulated request. You need to understand what they want, but you don't know what they want. Insight is a foundation for ideas. Ideas drive design. Number 2, take risks. Develop extreme designs and retreat when needed. Develop extreme designs. Push the envelope with what can be done. Think broadly. Then come back to the real world. You will not be respected as a designer if you proffer some small evolutionary tweak and never mention radical ideas to transform the product or entire market. Be creative and let your mind soar to all corners of possibilities. Don't let pragmatism hobble you. You will pull back into the practical soon enough. And I always mention in this, all your design should involve hovercrafts, antimatter, and all that sort of thing. You really need to push the range of things, and that's described elsewhere in the book. Number 3, identify deal breakers. Recognize foundational issues that will make your proposed design fail. You are always worried about safety, gravity, and money. Among other things. The high temperatures produced at Mach 3 prevented aluminum from being used in the Blackbird, so they had to use titanium. Once I was working on an ultra-portable printer, and one of the foundational problems was the size of the ink. I proposed either tapping into the user's blood supply or thermal printing. Ink volume was a deal killer for an ink-based approach to this design. Consider an example from the early days of the aviation. Wilbur and Orville Wright asked the right questions about what made an airplane fly. They recognized that poor flight control was a deal breaker, and they focused their design efforts in that area. Their contemporaries, such as Samuel Langley, were better funded and traditionally educated engineers, but asked the wrong questions. Langley burned up a fortune of research grants to develop a good engine without considering flight control. Langley's attempt at powered flight only 9 days before the Wright brothers ended immediately after launch with a broken wing and a crash. Number 4, make decisions quickly. Identify baseline decisions required for your design. These are the big decisions that let you start. In addition to being fast, the SR-71 was recognized as needing to be a flying fuel tank. That is, this thing was big engines and a lot of fuel. So all the design features wrapped around that. This realization, along with the requirement for fitting the most powerful engines available, drove the basic dimensions. The high temperatures required the use of titanium for most of the frame and skin. Every design detail requires decisions. Working out these design details is stressful, but you need to work quickly through them. Number 5. Think of your design as part of the system. Be willing to change the system. Does the system that supports it have to be changed, or should a new one be created? Remember, the SR-71 could not achieve its missions without aerial refueling. The F-117 could not be flown by a pilot. A computer operated the actual flight controls. So in other words, both of these airplanes were part of the system. In the case of the SR-71, it was in-flight refueling. It really couldn't do anything without that, and the F-117 could not fly without a computer. Sometimes your design requires fundamental changes in how things are done, such as containerized shipping, which I talk about in the book. A fascinating story. Number 6, trust your gut and chase your hunches. Design is not analytical or linear, it is something else. Trust your hunches. You are a creative beast. Your computer is not. You can process information and do magical things. Human insight is the spark we bring to design and engineering analysis. We must fight doubt with testing and encourage our beautiful creativity by following hunches. Number 7, design by building. Move quickly from mental concepts to sketches to rough prototypes. Do it at home if necessary. Flesh out concepts in a no-pressure environment, not at work. All the good stuff happens in your driveway, in your garage, and your backyard, and all that kind of stuff. Often with your own money. The SR-71 engineers were a short walk from the shop floor, so they could try out ideas quickly. Making an object real reduces dumb mistakes and helps you work more communally. We naturally connect with products that we can hold and operate. Make a rough prototype with your ideas out of paper, cardboard, wood, and other materials. This moves you to the real world quickly and lets you identify mistakes such as mechanisms that can't possibly work, pieces that don't fit humans, and parts that are very likely to break. It allows others to really understand your design and provide helpful input. Can't emphasize enough the importance of rough prototypes before you spend a bunch of money or time doing parametric models and 3D printing and these sort of things. Number 8, design for 99% of optimal. We want to make perfect designs, and anything less than this standard is painful. Who wants to be 99% excellent? However, approaching perfection takes time. It can drain every resource available, and the somewhat less than perfect answer may be the most efficient. One time I was trying to improve the durability of the design to our in-house standard. After spending a lot of time on the design, I had improved it a lot, but it was still far from my goal. My wise boss, and I had many of those, finally told me that the goal was not an absolute standard and we could change the goal. While this is contrary to my nature, if I hadn't accepted this notion of lowering a standard, I would have been working on the project forever. And usually that's a hard thing to do. You have a standard, a goal, a rule, and you think, well, that's what I've got to achieve, and which is good often, but sometimes you say, well, wait a second, that standard might not apply here. Anyway, Ben Rich, one of the Cold War presidents of Skunk Works, discussed in the book, put it this way, quote, "The only areas where the final result must be 100% are safety, quality, and security. That final 10% striving toward a maximum perfection costs 40% of the total expenditures on most projects. Skunk Works required the design only be 80% effective, and look at what they designed." So again, the 99% number, 80% number, you can pick what you want, but this leads right into number 9. Don't be a zealot. If something can't be made to work, redesign it. Don't fall in love with your design. The Fighter Interceptor, the YF-12 roll, was not a good one for a Blackbird and was discontinued, although it would serve as a flying wind tunnel for NASA for many years. So the YF-12 was a great airplane, but it wasn't really needed. Steve Jobs did not want a cooling fan on the early Macs, which was unwise. A bunch of the aftermarket fans quickly became available, and soon Macs had cooling fans included. More recently, Samsung recalled its entire Galaxy Note 7 phone because of its out-of-control burning battery. Market rejection of the product is more painful than a conference room rejection. So we fall in love with our designs, and that's a good thing. We're humans, we have emotions, and we have passions, and that's a great thing. Sometimes you have to stop it. Don't fall in love with something that can't love you back. That's not in the book, but an aphorism to chew on. Number 10, champion your design. Groups of people are good at generating ideas and providing helpful contributions. However, communal decision making can lead to bad things as you try to make everyone happy, which is my problem. I try to make everyone happy. While there is danger in having one person acting in isolation on a design, letting a group of peers drive a design can lead to everything looking like a Swiss Army knife. Autocratic design seems painfully undemocratic, but it's efficient. Number 11, share ideas. This is right out of the Skunk Works playbook. Make sure you bounce problems off with coworkers and anyone else who will listen. The solitary genius makes a great movie or a magazine article, but this is rarely the case. Read Jack Stillinger's book, Multiple Authorships and the Myth of the Solitary Genius, for more insight into this issue. And there he talks about Mozart and Einstein, and I could go on and on about that. I talk a little bit about it in the book, but it's an interesting thing. We like to put names and heroes with designs and other creative expressions, and often there's a bunch of people involved, including your mom. Number 12, use existing designs where you can, and your dad. Keep the big picture in mind and use products or systems that have had commercial success, even your teacher, even your professors. Keep the big picture in mind and use products or systems that have had commercial success. You don't want to reinvent the nut and bolt or the wheel. This approach complements the pursuit of 99% perfection, which may seem sad for a designer, but it is efficient and has a higher probability of success. The SR-71 cockpit is a tried and true oldie with nearly no innovation. However, it worked and could be trusted. So again, you lean or you stand on the shoulders of others, and if you try to reinvent certain things, I can tell you I've tried. Good luck. There's a lot of things that have been out there for a lot of years that are really, really, really good, really optimized. People know how to make them, how to fit them into your design, and there's some doors I close in my own world, like ball bearings and seals and wheels and just latches and all kinds of things. Number 13, don't be enslaved to procedure. This comes right from Johnson, from Skunk Works president, Kelly Johnson. The design is the goal, not the procedure. Procedures are especially good for ensuring the design is safe, can be efficiently manufactured, and is marketable. However, too much procedural interference at the early stages leads to plodding development. The designer has to have authority to design. So if you break out the piggy bank and work outside the work environment or in a maker space or something that's just kind of free, you can do things, you can make mistakes, and really, really important. Number 4, test until you can sleep soundly. Taking design risks and sleep don't seem to mix. Trying to fall asleep at night with your design churning in your mind is tough. This is why we keep a paper and pencil at our bedside. I lose a lot of sleep when I'm doing design work. Your tendency will be to achieve a good night's sleep by developing designs that are ultra-conservative or overbuilt. It is easy to overdesign things and make products that are too strong or have too much redundancy. You need to fight this tendency. Overdesign increases embodied energy, environmental impact, and cost, among other things. We talk a lot about that sort of thing. It's really easy to design safe. It's hard to innovate, hard to try new things. You need to test your design thoroughly. You need to carefully evaluate how your design will be used and misused. Then test and retest until you get a good night's sleep. So a good night's sleep could be the standard. Tough to do when you're innovating. Very tough to do. And then finally I have a comment here on design efficiency, because all these things seem to be tough and conflict, these 14 ideas. It seems hard to be a non-zealous product champion who takes risks, offends friends while seeking their input, and strives to design something less than perfect. Welcome to the world of professional design. However, let's not be melancholy. You know how to aim for perfection, how to create something radically new, and how to love your design. You just elect not to do these things for the sake of time and efficiency. Now, I have a few poems in this book that you can get in the book. I'll read this one because it's part of the last part of this section. So I end this presentation about design efficiency with a poem that shares my angst in design and other life challenges, called Planning. Tomorrow, talk to me. What do you have to say? What path shall I follow? What of yesterday? I stumble forward, grand plans cast away. Thank you.